Okay, welcome to 7.6. We are going to now have x on both sides of the equal sign. And we need a new procedure for that. It's different than the ones we've been doing. And you'll see that in this lesson. All right, so let's remind ourselves what we were doing in the last lesson, right? In the last lesson, the x's were always all on the same side of the equal sign. And when they're on the same side of the equal sign, you just combine them. So 3x minus x is 2x, and we get this two-step equation, 2x plus 6 equals 30. Over here, right, you combine your like terms and you get negative 3x minus 8. In both cases, at that point, you get a two-step equation, right? And then you just solve your two-step equation that remains. And in this one, it was x equals 12. Here you add 8 to both sides. And we divide both sides by negative 3 in this one, and you get negative 11 equals x. All right, so when they're all on the same side, combine like terms. Now look at this one. The x's are on different side of the equal sign. And what we have to do is somehow, by doing something to both sides of the equation, right, because that's the rules. When you do something in an equation, you have to do it to both sides. You have to do something to both sides that gets the x's on the same side. We want those x's on the same side, but you can't just move it over there. That's not a math thing. You have to do something to both sides that makes that happen or makes that one go over there, and we will see that. So we need to subtract enough x to get rid of them, to make them 0, to get rid of them on one side and get them on the other. Now, there is more than one way to do this, but my strong preference is I always get rid of them on the side where there are fewer x's. So let's look at this. All right, so we have x's on both sides, and what is smaller, 3 or 4? Well, hopefully everyone's going, duh, 3. So we're going to get rid of them where that coefficient is smaller. And so there are fewer x's there. So to get rid of that and make it 0, what do you think you do? Yeah, you don't divide like you normally might do in a two-step. What you do is you subtract that entire 3x, right? Because 3x minus 3x is 0x is 0. Those x's just go away. They've gone away. But what are the rules? If you subtract 3x from one side of the equal sign, you have to do it to the entire other side, right? And so the other side has that 4x. So 4x minus 3, and there's the answer. Now, they're not all that easy, but you're going to be adding or subtracting x's from both sides to get them on one side, okay? And so you show that. We are subtracting 3x from both sides there. All right, so let's do another one. All right, so first thing you do is you look at that and you realize, all right, I can't combine like terms because they're on different sides of the equal sign. So I'm going to have to subtract x to get them on one side. Now, what's smaller, 5x or 2x? 2x. So we're going to subtract them where they are smaller, right? We're doing this to both entire sides. You just write it under the like term. Okay, and so 5x minus 2x is 3x. 3x plus 8 equals negative 4. All right, so now this is more typical. What do we get? We got a two-step equation. We subtract 8 from both sides. Didn't really leave myself enough room here, but 3x equals negative 12, negative 4 minus 8, same as negative 4 plus negative 8. Divide both sides by 3, and x equals negative 4. But the key is, if it's to get rid of 2x, you subtract 2x. Okay, now this time we have to get rid of negative 4. Well, we have to get rid of negative 4x. Now, why do we have to get rid of negative 4x? Because, right, negative 4 is smaller than 2x, right? So we're going to get rid of them where there are fewer x's. So to get rid of the negative 4x, hopefully we all can guess you add 4x, right? Because negative 4x plus 4x for any value of x, 1,000,000 or 3.4 will equal 0. And so we can cross those out. Then we add 4x to the other side. 18 now equals 6x. That's a one-step equation. Divide both sides by 6, and 3 equals x. Now, Can you subtract the 2x and get it over there? Some teachers do it that way. The issue is you really want this coefficient of x to be a positive number. It saves you headaches down the road if this coefficient is always a positive number. And so I just make that happen. And so the way you make that happen is always get rid of the x's where there are fewer of them. All right, so what's smaller, -3 or -5? Hopefully everyone's saying -5. So we're going to get rid of them where the -5 is. So we're going to add 5x to both sides. You'll know if you haven't done it right, because if you get a negative number in your two-step, you've messed that part up. Now you can still get it right as long as you do everything to both sides correctly. But I got a two-step equation. I add 8 to both sides. 2x equals 10, divide by 2, and x equaled 5. All right, so we're just going to practice a whole bunch. So we're going to get rid of the 2x from both sides. 5x minus 8 equals 12. There's our two-step. We're adding 8 to both sides. 5x equals 20. Divide by 5. That's a very sloppy 5, but x equaled 4. And let's understand. 7 times blank minus 8 equals 2 times blank plus 12. There's only one number I can put in that blank. It has to be the same number on both blanks. That will make the whole math work out. If you notice with 4, both sides equal 20. No other number will make both sides of the equation equal the same number. That number is called the solution. Okay. So I'm going to add 4x to both sides because -4 is smaller than 6. 29 equals 10. Oh no, I'm subtracting. I almost added there. Equals 2x minus 1. Add 1 to both sides. 30 equals 2x. Divide by 2. 30 divided by 2 is 15. 15 equals x. What's smaller? Yeah, -5 is smaller. So we're adding 5x to both sides. 3x plus 2 equals 29. Subtract 2 from both sides. 3x equals 27. Divide by 3. X equals 9. All right, so now we have x's on both sides and we have x's on the same side. It's a combination of the 2 days. So what do? What you want to do is combine the ones on the same side first. And the reason is you want to be able to tell how many x's you have on that side, right? Because you're not going to be able to tell where you have the fewer x's unless you've combined them all on each of the sides. Okay, so now I know I have more x's on the left. I want to get rid of the 2x. Okay, so I got 7x plus 15 minus 6 turns into -6. Subtract 15 from both sides. -6 minus 15 is -21, right? Same as -6 plus -15. Divide both sides by 7. X equals -3. Same thing here. So I have 4x minus 6x. So x plus 21. What's 4 minus 6? -2x minus 9. All right, where are they fewer? With the -2x. So we're going to add 2x to both sides. 3x plus 21 equals -9. Oops, -9 is my two-step. Subtract 21 from both sides. -9 minus 21, same as -9 plus -21, -30. Divide by 3. X equals -10. Okay, and remember, answers can be fractions. Now, in this case, this is the one case where adding 6x, because here is not going to be faster, but I want to do it just to show it. -6x plus 6x, you cross that out, you get 0 here, right? That's why you've been able to cross it out. So I want, this problem here is to make sure you know that for one. All right, so here we get 5x plus 1. This answer is not a fraction because you're going to be, oh yes it is a fraction because you're going to subtract 1 from both sides. 0 minus 1 is -1 equals 5x. Divide both sides by 5. Yeah, and the answer is -1/5. All right, but this problem is there because of fraction answers, but it's also to make sure you understand that that becomes a 0 there. Okay. All right, so their x is on the same side. When we see that, we're going to combine our like terms. So that's negative 4x minus 5 equals x minus 29. So we're now going to add 4x because negative 4 is smaller than 1. We're adding 4x, and we get negative 5 equals 5x minus 29. Add 29 to both sides. Is that right? Oh, that's right. Answers can be fractions. Okay? That's why, and the answer is 24/5. That's a simplified fraction, right? If you feel compelled, 20/5 is 4, so this is also 4 4/5, and 4 4/5 is also equal to 4 8/10, right? So it's also 4.8. It's all of those, but the easiest one is 24/5. All right, so let's practice. All right, do them all and then check your answers with me. Subtract 2x from both sides. 5x equals negative 30. Divide by 5. X equals negative 6. All right, get rid of the negative 4x because it's smaller than 2. And you get negative 13 equals 6. I add 4x. I always write what I'm doing there. There's a two-step. I'm going to add 25 to both sides. Negative 13 plus 25, I believe, is positive 12. Divide by 6. 2 equals x. All right, whoop, I'm going to combine like terms first, right? And so I'm adding that. So I get 8x minus 6 equals 3x plus 9. I almost started too quickly there. All right, so subtract 3x from both sides. Yes, can you do these in other orders? Yes, you can. This is just my experience showing you the order. Could you have subtracted 3x from both sides? Yeah, but you want to make sure that was the side with fewer. So 9 equals 5x minus 6. Add 6 to both sides. 15 equals 5x. Divide by 5. Both sides. I ran out of room, but 3 equaled x. Okay, 7 plus 3x equals negative 5x plus 10x. So I haven't done, yes I have, 5x. Okay, so what are we going to do here? We're going to subtract 3x from both sides. 7 equals 2x. Divide by 2. We're going to get a fraction. 7 halves. Perfectly good fraction. 6 halves is 3, so it's also 3.5. It's also 3.5. Any of those is good. All right, so we have to match one of those equations. Let's see. Well, this is x plus 27 equals 5x minus 1. Okay, I'm going to get rid of them where they're fewer. 27 equals 4x minus 1. Add 1 to both sides. 28 equals 4x. Well, I don't have exactly that, but is 4x equal to 28 the same thing? Yeah, and that's called the symmetric property, that both, whether you write 28 equals 4x or 4x equals 28, equivalent. They are equivalent equations. Good luck with the homework.